Hi everyone, we are Team Hack Flow. Today we will be talking about the website we made for the course Scalable Internet Services, which is called eKirana. This is an online e-commerce website that serves the purpose of connecting local vendors with a wider set of customers. The website is named after the word Kirana, which refers to local street shops in India. The idea was to provide an e-platform to such businesses so they can market their products to a larger audience. The technology stack used for building the e-commerce site is Ruby on Rails.
Okay, now let's take a look at our website. So this is the homepage of our website where we can see all the items that are present in our website in a detailed manner. So we can also view detailed view of each item. We have provided an aggregate rating based on the average of all the users' ratings. Let's log in as buyer and see how our website looks. Yeah, so once you log in as an editor, you get an option to add a certain item to cart. So let's add this laptop to the cart and let's visit our cart. So we have JavaScript functionality to calculate the overall cost and also to increase the quantity up to 10. And then we have also JavaScript functionality to delete the item from the cart. So once you place the order, you just get a static page saying thank you for shopping with us. Then if you visit your orders page, you can see all the items you have ordered, and you can rate the items. So you can submit a 5-star star based rating with some comment like say good. And yeah, so based on your ratings, the order will be updated. Now let's log in as a seller and see how the seller's view looks. Yeah, so the seller might not is not able to add any items to the cart. Okay, now, but if he visits his profile, he can view all the items that he has created, and he can check the respective ratings for them as well. And he can add a new items where he can provide the name and description and the price for the item, and he can register it, and it will show up in the.
Okay, so here are our data models. We have 6 models which are buyer, seller, cart, item, order and rating, and this is our entity relationship model. Now let's talk about testing our application. In order to test the eKirana, we came up with 5 different test workflows. Every test workflow is a simulated user behavior typical to any e-commerce platform. Let's go over each workflow one by one. So this is our first workflow where a buyer logs in, visits his home page and browse random items and logs out. This is a workflow 2 where the buyer logs in, views an item and its rating and then adds it to the cart. Finally, he visits the cart page and logs out. Now this is workflow 3 where the buyer logs in, adds a couple of items to the cart, visits the cart page and places the order before signing out. For the workflow 4, the buyer signs in, views all his orders and randomly rates an item before leaving. Coming to workflow 5, this is designed to simulate the seller activities. Here the seller signs in, checks his profile and then adds an item, then checks the home page to verify if the item is present in the home page or not, and then visits his profile and signs out. So with these workflows, we were able to simulate all the different kinds of behaviors.
Move on to optimizations now. These are the optimizations that we performed: pagination, caching, N+1 optimization, and indexing. Let's move on to pagination. Initially, our database was seeded with 10,000 items and the home page was displaying all the items at once. With pagination, we reduced the number of items on each page to 10. After pagination, we found significant improvement in mean duration of request. As you can see, it almost remained constant until phase 4. The max of mean duration got reduced from more than 20 seconds to around 7 seconds. We can also see an increase in number of 200 and 302 responses in each phase. And from the graph, you can also see the number of 502 errors reduced a bit and started only from phase 4. After pagination, we moved on to caching. We implemented both Russian doll and fragmentation caching and saw improvements in workflow 4. With caching, the contents were retrieved from server memory instead of from the database every time, hence improving the performance. As you can see, the mean duration in phase 3 reduced from 6 seconds to less than 3 seconds. The number of 200 and 302 responses also increased. After caching, we did N+1 optimization. As we have multiple relationship between tables, we were executing multiple queries to the database, and to improve that, we implemented N+1 optimization. We saw improvement on workflow 2 with this optimization. And from the graph, you can see the mean duration reduced in both phases 2 and 3. At last, we also included indexing, but did not get as much improvements as we got in other optimizations.
Let's discuss vertical and horizontal scaling our app and database server instances. While optimizing our various test workflows already discussed, we started with C5 large app instance and M5 large database instance. After optimizing all our workflows, we combined them together by assigning certain probabilities based on typical user behavior. Hence, it was quite logical that we start testing the impact of vertical scaling. We scaled our app server from C5 large to M5 4x large and our database instance from M5 large to M5 2x large, and we found tremendous improvement in the number of 200 and 302 responses. The mean duration of the request decreased with every step, but we still saw few connections being dropped, and hence we decided to scale horizontally. We thought with horizontal scaling we could handle the errors and dropping connection issue. So we horizontally scaled the app instance by a factor of 2. Even after scaling the app instance by a factor of 2, we still saw and encountered some 500 errors, and hence we decided to further scale it up to 4 instances. As you can see, the mean duration of request is now almost constant and also well below 200 milliseconds.
Okay, now let's talk about database record scaling. When we started our load testing, we initially seeded our databases with 10,000 items and corresponding number of cart and order entries and other models. So we wanted to test the impact of increasing these database records and see if there are any bottlenecks from the database side. So we increased the number of database entries to 50,000 items, then 100,000 items, and then finally to 500,000 items. And we also increased the number of records for other models accordingly. We used 4 M5 4x large instance for app server and 1 M5 2x large instance for the database server. And in all of these tests, we were not seeing any 500 responses, and all the responses were 200 or 302 HTTP status responses. The request mean duration was also well beyond 200 milliseconds. We were seeing a few spikes in the last phase, but we probably guessed that this might be due to the load balancer warming up. We performed the test for 500,000 items later, so we were not seeing any request mean duration spikes in the last phase, and it was also well below 200 milliseconds. So we are confident that we would get the similar result in case of a million items also. We then wanted to test the impact of our website when the number of users per second increases. So in all the previous tests, we capped the number of user arrival rate to 128 users per second. So we wanted to increase this and see the impact of it on our website. So we increased the number of phases from 128 to 256 to 512 and then finally to 1024 users per second. So we wanted to check what is the best configuration that would support each user arrival rate. So we plotted this table for that, and we also calculated the cost per hour for that configuration. So our criteria was that then there should be no 500 HTTP responses and the request mean duration should be less than 200 milliseconds. So in that regard, we saw this is the best configuration for the corresponding user arrival rate. And so we also plot a graph for the user arrival rate versus cost per hour to see how we were getting any diminishing returns. And we used a semi-log graph on the x-axis because the larger quantities were dominating the lower ones in a linear graph. And so as you can see here, there is a quite sharp spike here. So we were getting some diminishing returns, and we proposed a few remedies in our report.
So that was all that we wanted to discuss about eKirana and our e-commerce website. These are some of the important features that we could also integrate and make the website more complex, such as integrating a payment gateway or maybe adding features to each of the items that we are trying to sell, or we could also end up integrating a search engine. Thank you so much for listening to us. Hope you could gain something out of the video.